Hey, if you are new here, this is Chandan and you are watching the learning field. Okay, so this is the lecture 6 of linear programming problems series. So this is the this is very helpful for GATE exam and CSIR NET and any state level set examination. Okay, so in the last lecture, that is in lecture 5, we discussed simplex method, okay, and different theorems and examples of simplex method. And in this lecture we continuing the simplex method, and in this video we are discussing another method, which is the BGAME method, okay, which is known as Charnes BGAME method. Okay, Charnes BGAME method. This method is also method based on simplex method. Okay, so let's start. And before starting the solution, before starting the class, I am requesting you all, those who are new in my channel, please like the video, comment if you have any doubt in the comments section below, and subscribe the channel. Okay, so let us take first an example of an LPP. In the last video we discussed the simplex method with the equality type of constant. Okay, so in this lecture we take the example of inequality, that is less equal to type of constant. Okay, so inequality type of constant, okay, basically. And in this question, or in this problem, okay, the theorem, minimax theorem, is also here needed for this okay problem. Okay, so see the problem. Use simplex method to solve the LPP. Minimize z equal to x1 minus 3x2 plus 2x3 subject to the constant 3x1 minus x2 plus 2x3 less equal to 7, minus 2x1 plus 4x2 less equal to 12, and minus 4x1 plus 3x2 plus 8x3 less equal to 10. Okay, so this is the problem. And one more thing is that the PDF of these classes are already available in the Telegram channel of the learning field. Okay, so you can visit the Telegram channel for the PDF and joining the channel for your future reference. Okay, the name of the channel is the learning field official Telegram channel. The learning field, the name of the channel is the learning field. Okay, so the PDF of these lectures will be provided in the channel. Okay, and see here we also introduce slack variable and surplus variable and another variable which is known as artificial variable, which we discussed later. Okay, so first first we have to do what? The first work is we have to change this inequality type of constant to the equality. Okay, so for this, since this is less equal to type of constant, therefore we have to introduce the slack variable. Okay, so introducing slack variable, there are three decision variables, x1, x2, x3. We introducing x4, x5 and x6 for three inequalities. Okay, so and rewrite the problem in the standard form, that is here we use the minimax theorem. Okay, the minimax theorem. Okay, so maximum of z dash equal to minus minimum of z dash equal to minus multiplied this objective function by a negative sign. Okay, plus 0 into x4 plus 0 into x5 plus 0 into x6 since these are the slack variables. Okay, therefore the constant are this one, 3x1 minus x2 minus x3 plus x4. This is the slack variable for the first constant, this is the slack variable for the second constant, and we write the equality type of constant. Okay, so this is the third slack variable for the third constant. Okay, so x1, x2, x3, x4, x5, x6. Okay, so xi greater or equal to 0 for I equal to 1 to 6. Okay, now we have to choose the initial basic feasible solution. How we can choose the initial basic feasible solution? See, here x4, x5 and x6 form the basis. Okay, the coefficient matrix of x4, x5 and x6 are like this: 1 0 0, 0 1 0 and 0 0 1. See carefully, this is the coefficient of x4, that is the first slack variable, this is the coefficient of the second slack variable, and this is the coefficient for the third slack variable. Therefore the initial basic feasible solutions are corresponding, the value corresponding to the x4, x5 and x6. Okay, that is the initial basic feasible solution we take here is 0 0 0, 7, 12 and 10. There this 7, 12 and 10. Okay, so this is the initial basic feasible solution. Now the starting table for the simplex method we write. Here we write the CJs, since and the cost corresponding to the slack variables are obviously must be 0. Okay, so 1, minus 1, 3, minus 2 are the cost corresponding to what? Corresponding to the basic variables x1, x2 and x3, and the cost corresponding to the slack variables x4, x5 and x6 are 0 0 0. Okay, and this is the CB, BXB, the basic basis for the basis matrix for the this basis forms what? The variables x4, x5 and x6, the slack variables. Okay, so the cost corresponding to the slack variables are 0, we write here, and the basis vectors are a4, a5 and a6 for the corresponding to the basic corresponding to the slack variable x4, x5 and x6. Okay, we write the b's here, that is 7, 12 and 10, and the coefficient matrix is 3, -1, 2, 3, -1, 2, 1, 0, 0, the coefficient of the second constant, so -2, 4 and 0, 1, 0, -4, 3, 8 and 0, 0, 1. See here, this is the basis matrix. Okay, the slack variables from the basis matrix. Okay, basis or basics. Okay, basis. Okay, now we calculate the zj minus cj term. We already say how to calculate the zj minus cj term. So the zj minus cj term corresponding to the basis vectors are 0, that is, since a4, a5, a6 are the basis vectors, therefore zj minus cj terms are 0. We don't need to calculate these terms. Okay, now we calculate for the a1. So this is -4 into how to calculate this, -4 into 0 plus -2 into 0 plus 3 into 0, this -1, that is, this is 1 only, and this is the -3, since this into this 0, this into this 0 and this into this 0, -3, that is -3, and this one is 8 into 0, 0 into 0 and 2 into 0 minus -2, that is 2 only. Okay, so this is the what, this is the zj minus cj term for all j. Okay, now we have to find the entering vector and departing vector from the basis. Okay, and the departing vector. So how we can find the entering vector and departing vector? We see, we say that what, the negative most terms of zj minus cj corresponding to that vector enters the basis. Okay, that means what? That means here a2 enters the basis in the next table. Okay, here a2 is the incoming vector. Okay, now to find the departing vector, we need to find the mean ratio corresponding to this vector. Okay, so mean ratio corresponding to this vector is x1n by yi2, where yi2 greater than 0. yi2 means these elements. Okay, yi2 means these elements, -1, 4 and 3. Okay, since this is negative term, therefore we avoid this term. So 7 by negative, we avoid this, and now the second one is 12 by 4, which gives 3, and 10 by there, this is 3. Okay, so this is what, this is the 3 into 1, 3 upon 3 and 1 upon 3. Okay, so the minimum of this ratio is this one 3, therefore the minimum most leaves the basis. That means what? That means here a5 corresponding to that vector is a5 leaves the basis. Okay, so the outgoing vector is a5, and this 4 where the intersect this term and this term, this 4 is called the key element. We already discussed this. Okay, so this is the key element. Okay, now we go to the next table. Okay, and the elementary row operation here, this is the elementary row operation, you can say, but we avoid this row operation and we just take the calculation. We already say this. Okay, how the calculation is made here. Now we need to convert this element to unit, therefore we divided this whole row by the key element, that is 4. Therefore this gives 3 minus of 1 by 2, 1, 0. These are the elements dividing by 4. Okay, and now we calculate these elements and this row, first row and third row, by how? By this, just here erase this once. Okay, how we calculate this? We calculate how this 4 constant. Suppose we find this element. Okay, suppose we find this element here. This element means this into this minus this into this. Okay, so 7 into 4, 28 minus of 12, minus of minus 12, that means what? 28 minus of minus 12 means plus 12, that is 40. 40 divided by 4 means 10. What? Okay, so this is the 10. Okay, and since here now first we write the CBB XB term. How? So a5 outgoing vector and a2 is incoming vector. Okay, so we write here a2 instead of a5. Okay, so a2 and a4 and a6 are remaining the same, so corresponding the basic variables are x4, x2 and x6. Okay, and the corresponding to corresponding cost of the variables, cost of the variables x4, x2 and x6 are this is what, this is x4 corresponding cost is 0, a2 means 3 and x6 means again 0. Okay, so these are the cost, we put it here. Okay, and now we calculate this element. How this element we can find? So this means here see, oh sorry, since this is the vectors which is present in the basis, therefore this is the 1 0 1, the terms are 0. Okay, and the we calculate the next one, that is calculate this element. How we calculate this element? See, this into this minus this into this by 4. Okay, so 4 into 3 means 12, minus plus again minus 12 minus 10 means 12 minus 2 means 10, 10 by 4 means 5 by 2. Okay, so we get 5 by 2. Okay, so in this way we calculate this table. Okay, you can calculate this table. So this is the table, you can check once. Okay, I don't go to the details calculation. Okay, so now we write how. I think you should understand this table. How can we calculate this table? Okay, and all the elements you can calculate once for your reference. Okay, so now zj minus cj term we calculate here, the zj minus cj term. Okay, so zj minus cj term, and here also we calculate, we see that here also zj minus cj, 1 zj minus cj is negative, therefore this table does not satisfy the optimality condition. Okay, and in this table also, since there is one negative term, therefore this is not the optimality condition. What is the optimality condition? Zj minus cj greater or equal to 0 is the optimality condition. Okay, so here the optimality condition is not satisfied, therefore we proceed further. Okay, so this table comes. Okay, first iteration. Now since here also the same, for applying same calculations, we get one negative term, that is zj minus cj. All zj minus cj are not greater or equal to 0, therefore we go to the next step. Okay, so this is the table, and now how we calculate here the entering vector and departing vector. How? See, here this is the table. Suppose I just erase these things. Okay, so this is the table. Now see, since this is the negative one, only one zj minus cj is negative, therefore this must be the entering vector, therefore a1 enters the basis. Okay, a1 is the incoming vector. Okay, now we calculate the mean ratio corresponding to this row, this column, that is 10 by 5 by 2, this gives 4, and since these are negative, therefore we avoid these two. Okay, so only one, that is this is only the departing vector from the basis, that is here a4 is the outgoing vector from the basis, and this is the key element. Okay, the intersection of these two lines gives the key element. Okay, you get the key element. So the key elements we get, therefore a1 is incoming, so we write a1 instead of a4 in the next table in the basis vector. Okay, so this is the table, and now in the similar way, this is the second operation, you can say it, this is the operation you can apply, otherwise the method will say, we just said you can apply. Okay, so this is the second table, and we now see the zj minus cj term. All zj minus cj are greater or equal to 0. Okay, so all zj minus cj are greater or equal to 0, that means this satisfies the optimality condition, and this gives the optimal solution. Okay, so here see that a1, x1, x2 and x6 are present. Okay, so this gives the what? This gives the optimal solution, and since x6 is an what? Slack variable, therefore the this is not included in the optimal solution. We just have to calculate x1, x2, value of x1, we just need x1, x2 and x3 value. Okay, value of x1, x2 and x3, and since x3 is not present in the basis, therefore we take the values of x3 is equal to 0. Okay, so since zj minus cj greater or equal to 0 for j equal to 1 to 6, so the primal solution, the optimal solution is obtained, and the optimal solution is x4 equal to this 6 by 4, x2 equal to 5 and x6 equal to 11, that is this is the slack variable we take as 0. Okay, so this is the solution, and minimum of z equal to what? 4 minus 3 into 5 plus 2 into 0, this is equal to minus 11. Minimum of z means maximum of minus of z. Maximum of z equal to minus of minimum of z. You just need to check this value for the variables. Okay, so this is the solution of the simplex problem. Okay, of the LPP. Okay, Now we comes to another important method of simplex method, which is Charnes Begin method. Okay, so this is another important theorem. In the previous problem, we take the less equal to type inequality. Okay, but when the case comes for the greater equal to type inequality, then how we can solve the problem? Okay, for this, to solve that problem, so which includes the greater equal to sign, we need to know the Charnes Begin method, or simply big M method. So okay, so see the story or method. So see, what is the method? If the constant of the LPP are greater or equal to type, then we subtract the surplus variable. Okay, so we calculate the above last problem using the slack variable. Okay, and when the greater or equal to type constant come, therefore we introduce surplus variable. We discussed it above. Okay, to get the LPP, the standard form. Okay, but the column vectors corresponding to the surplus variables do not provide the unit vectors for the initial basis. Why? Since we subtract the quantities, suppose minus x, okay, so the coefficient is -1, and minus of unit obviously do not form the basis. Okay, so to form the basis, in order to have unit vectors in the basis, new non-negative variables are brought in. Therefore क्या करना है हम लोगों को यहाँ पर और न्यू वेरिएबल्स को इंट्रोड्यूस करना है बेसिस फॉर्म करने के लिए. ठीक है, तो दे आर कॉल्ड द आर्टिफिशियल वेरिएबल्स. ओके, so when the case of surplus variables comes, there must comes the case of artificial variable. Okay, because why? Because the surplus variables can't from the basis. Okay, so the column vectors of the coefficient matrix corresponding to this artificial variable are called the artificial vectors. Okay, while introducing artificial variable, constant are not affected. Okay, and one more thing, this ये जो लिखा है ना यहाँ पर, ये सबसे इजी लैंग्वेज में लिखा है. ठीक है, अदर कोई भी बुक देखो तो इतना इजी लैंग्वेज में आप लोगों को नहीं मिलेगा. ठीक है, सो सी, इन फैक्ट सच आर्टिफिशियल वेरिएबल्स आर compensated by paying a very huge price. Okay, they are fictitious, fictitious. Okay, and merely added so that we have ready to IVFS to start the simplex method. Otherwise, they have no physical significance, and as such need to be removed from the optimal solution. In some constraints are greater equal to or equal to type, and there is no unit matrix in the coefficient matrix, then artificial variables will be introduced. Okay, so when artificial variable is to be introduced, when the greater equal to type inequality and equal to type of inequality occurs, but there is no unit matrix is to be formed, then we introduce the artificial variable to form the unit matrix. Okay, or unit basis. Okay, to form the basis. So now we comes to the big M method. The big M method is designed to remove the artificial variable from the basis. Okay, according to Charnes, a very high penalty can be paid introducing the artificial variables in the constant of the given LPP by assigning a very large negative cost in case of maximization problem and a very large positive cost in the minimization problem. We try to solve the problems of minimization problem. First we convert to maximization problem, and then we apply the method. Okay, and it is I think easy to apply this method. Okay, so my suggestion is that first we convert the LPP to the standard form. Okay, that is to the maximization problem. Okay, artificial variable in the objective function. The method of solving LPP by assigning huge penalty cost or the artificial variable is known as method of penalty, or Charnes M technique, or big M method. Okay, so this is the method. This is the story behind the Charnes big M method. Okay, and there are three case holds in the optimal solution. Case one is no artificial vector presence in the basis. Okay, that means what? In this situation we get an optimal solution of the LPP, and hence the constant equations are consistent, having no redundancy. Okay, and the second case is one or more artificial vectors present in the basis and the corresponding artificial variable appear to at the zero level. Okay, and the third one is one or more artificial vector present in the basis and the corresponding artificial vector appear at the positive level. Okay, so these three cases occur, and in the second case the solution obtained in the primal, and hence the constants equations are consistent through one or more constant may be redundant. Okay, and the LPP has no feasible solution in the third case. This may be due to the inconsistent of the constant equation, or it maybe the system has solution which is not feasible solution. Okay, so these three cases may be occur. I will provide the PDF in the Telegram channel. You can download the PDFs and read it once, obviously. Okay, this is very important to go through once from these PDFs or from these methods. Okay, because I think it is not easy to understandable at first chance. Okay, so you just see the PDFs and practice one or more problems to understand this method properly. Okay, so my request is that you go through these PDFs or any book you have in your purpose in your, so you go through just once to this method and solve one or two problems. Okay, depending on these methods. Okay, so let us take an example of this method. So minimize z equal to x1 plus x2 subject to this one. See, these two are greater or equal to type of inequality. Okay, so introducing surplus variable to convert this inequality to the equality x3 and x4, and since x3 and x4 we subtract from the left side, therefore this can't from the basis, so we need to introduce the artificial variable x5 and x6 to obtain the basis. Okay, and rewrite the LPP, and we convert the minimization problem to the maximization problem first. Okay, see, subject to the constant, this and this are the what? This is the surplus variable and this is the artificial variable. Okay, so for this are greater or equal to 0, where m is a sufficiently large positive number. Okay, and m is the coefficient of the artificial variables. Okay, with a negative sign. Okay, large m is the large positive number, and here we write the minus m. Okay, for the maximization problem we take the cost minus m, which we just say in this here. Okay, just go through it now. Now what? Since x5 and x6 are from the basis, therefore we take the IBPSS 0 0 0 0 and 4 and 7 corresponding to x5 and x6. Okay, so now we write the table. So CB, BXB term a5 and a6 here the from the basis, therefore a5 and a6 are in the basis, and x5 and x6 are the variables corresponding to the basic vectors. So these are the presents here, and m and minus m are the cost of the variables x5 and x6. Okay, so Cj is here, and now we write the coefficient 4 and 6 here, 4 and the coefficient of this here. So now we write calculate the zj minus cj term including m. Okay, so minus 3m plus 1 and minus 8m plus 1, m and 0. Okay, so m is a positive number, therefore these four quantities are positive, and minus 3m plus 1 and minus in between minus 3m plus 1 and minus 8m plus 1, minus 8m plus 1 is more or big negative number, therefore this is the entering vector. Okay, and we calculate the mean ratio corresponding to this vector a2, and we get 4 by 1 and 7 by 7, that is 4 and 1, and the minimum most vector enters the basis, that is here leave the basis, that is x6 leave the basis, and a6 leave the basis, and a2 enters the basis. Okay, so a2 entering vector and a6 leave the basis, therefore a5 and a2 here from the basis. Okay, a5 and a2, so we write the cost corresponding to a5 and x5 and x2. Okay, these are the cost corresponding to this, and we just calculate similar calculation you can do, and here also write the iteration. These are the calculation methods you can apply here, and you get and here 7 is the key element. We all know that how can key element comes. Okay, so now the second, after first iteration we get the zj minus cj term, this one and this one, these two are negative terms, and here this is the negative most number, therefore a1 enters the basis, and we calculate the mean ratio corresponding to this 3 by 13 by 7, which gives 1 and 8 by 13, and this gives 7, and minimum most is this one, therefore a5 leave the basis and a1 enters the basis. Okay, so a1 entering the vector and a5 is the departing vector, and this 13 by 7 is the key element, since this is the intersection point, so this is the this is the key element. Okay, so the next table is similar calculation. Okay, the next table is this one we get, and this is the iteration, you can apply it here. Okay, so this is equal to what? A1, and in this case A1 enters the basis. Okay, so A1 enters the basis, therefore this is the calculation Zj minus Cj, and we see that here Zj, all Zj minus Cj greater or equal to 0, therefore this is optimality condition satisfied, therefore our problem is solved. Okay, since all Zj minus Cj greater or equal to 0 and the artificial vectors A5 is not present in the basis, that means what? In the basis there are no artificial vectors. Okay, if the artificial vectors present in the basis in a positive level or in a 0 level, then the cases are here. Okay, case 2 and case 3. Okay, so read it properly. Okay, so optimality solution is obtained, and the optimal solution is x1 equal to this and x2 equal to this. Okay, so x1 equal to this and x2 equal to this, and minimum of z3 equal to, just put the values of x1 and x2 in the objective function to get the solution. Okay, so this is the method, bgame method and simplex method using the slack variable, surplus variable and artificial variable. Okay, so this is the content for this video. If the content is helpful, then please give a like to this video, share with your friends, and if you have any confusion, then you can comment me in the comment section below, or you can say me in the telegram channel. The telegram channel link will be in the description, and also you get the link of the telegram channel in the about channel in the YouTube. Okay, here about channel section you can get the link of telegram channel. So I request you subscribe the telegram channel to get the PDFs and many other things. Okay, so thank you, see you again in the next video.